All right, so for this deep dive, we're looking at a piece of hardware that, honestly, it sort of defies the old rules of AV over IP.
It really does.
We're talking about the Aurora VPX-TC1-Pro. And the big question, our mission here, is how on earth it pushes perfect ultra-high-def video over a standard 1 gigabit network.
That's exactly it. That's the challenge, right? A raw 4K 60 stream with full 4.4.4 color needs something like 18 gigabits per second of bandwidth.
So you're trying to fit all that down a tiny 1G pipe.
Precisely. It just shouldn't work. And the answer, the real breakthrough, is this new Mimics codec technology that Aurora is using. Is what makes visually lossless results even possible here.
Okay, so let's get into the specifics of that. We're looking at Mimics compression, and the ratio is what, 8.1?
Yeah, 8.1. And to do that with full 4.4.4 color without seeing, nasty artifacts is, well, it's the whole game right there.
So what are the actual numbers we should be looking at? What are the key performance metrics?
It's all about speed. The latency is the number that really jumps out. We're talking one single frame.
One frame, so like 16.6 milliseconds.
Exactly. For any professional environment, that is essentially real time. This is then paired with seamless switching.
Meaning no black screens, no lag when you change sources?
None. It's just instant.
And it's not like they're compromising on the visual standards to get there.
Right.
It's built for today's content. You've got full HDMI 2.0B, HDCP 2.2, and 2.3.
And all the critical HDR formats.
Yeah.
HDR10, HDR10 plus Han4O, even Dolby Vision. It checks all the boxes.
But the performance is only half the story, isn't it?
I think the efficiency is just as revolutionary as the speed. Yeah. We have to talk about the operational side of this.
The power draw.
The power draw. This is a low-power, completely fanless box. It consumes as little as 8 watts.
8 watts. That's nothing. That's the real operational win here.
Oh, absolutely. Think about scaling that. If you have 100 of these across a corporate campus, you're looking at monumental savings on your utility bills.
It's about a third of the power of some older systems, right?
At least. It totally changes the long-term cost of ownership.
And the flexibility is another big point. This isn't just an encoder or a decoder.
No, it's a transceiver. You buy one box, one SVU, and you just configure it in the software to be what you need it to be.
Which has to make inventory a lot simpler for installers.
So much simpler. And it's TAA compliant and tariff-free. So it's a cost-effective solution right from the start.
Okay, so what about the physical connections, the I/O?
It's pretty robust. You get 2 HDMI inputs and 1 HDMI output.
And for the network?
There's a 1G LAN port with PoE, plus you get an SFP port. That gives you the option for fiber or even a second copper connection.
Very flexible. But you were saying the audio and security are where it really gets high-end.
Yeah, the architecture here is impressive. It supports LPCM audio up to 12 channels. We're talking Dolby True HD, DTSC Master Audio.
Dolby ATMOS too?
Even Dolby ATMS. And remember, that's all going down the same single 1G pipe as the 4K video.
That's incredible. And for more sensitive jobs.
It's got enterprise-level security baked right in. AES 256 encryption. So it's ready for critical infrastructure or government applications out of the box.
And they didn't forget the pro installers either. You mentioned video wall support.
Full video wall capability, including image rotation, which is vital for many digital signage and control room setups. And there's an optional Dante audio card if you need to integrate with a networked audio system.
So if we boil this entire deep dive down, what we're really seeing is a device that delivers that top-tier, pristine 4K 60 4.4.4 experience.
Right, but without the top-tier infrastructure that usually requires. It does it all on a standard 1G network.
And it does it using just 8 watts of power. It basically proves you don't need that expensive, disruptive 10G network upgrade for premium quality.
Exactly. Which kind of leads us to our final provocative thought.
Right. So if you can now get this level of performance near zero latency, perfect video on the standard 1G infrastructure that is already everywhere.
Yeah, and do it so efficiently. What's next? What major applications previously held back by bandwidth and infrastructure costs, like advanced medical imaging or professional flight simulators, are now suddenly unlocked and ready to be revolutionized?